All right, so we're recording. So today I am going to explain the Solpipe tool, which is a set of Golang tools, to Miguel, who is I guess, full stack developer. I mean, React, soon to be Golang developer. Yes.
Yep.
Cool, cool. All right, so first, yeah, I see that you're on the slide deck. Let me start the slideshow. Um, So Solpipe. So Solana is a blockchain. It's it's a proof of stake blockchain. Um, let's see. There's smart contracts on it, so it's kind of like an Ethereum version 2.0. You have abstract concepts. Smart contracts are called programs. You still have transactions that are bundled into blocks and that are published in a time schedule, 1 block per slot, roughly speaking. And a block is it takes about 2.5 seconds for a block to come out. The smart contracts via the programs, the state is stored in accounts. So in Ethereum, the accounts and programs are kind of merged together in a smart contract in the output of a transaction. But in Solana's programs are separated from accounts. Yeah. So what we're doing is so basically developers have an issue where they have transactions, and transactions the developer wants to, for example, send money from person A to person B. So they'll call a token program and they'll input the account of the person they're sending money to and the token account of the person they're sending money from. There are many different kinds of accounts. In this case, we're transferring, Alice is transferring USDC to Bob. USDC exists as a token in Solana, which uses the token program. So Alice needs to sign a transaction that tells the token program to transfer money from her token account to Bob's token account. Right. So in a proof of stake system, what we're focused on is how does Alice get this transaction into a block? So if you go to the Solana website, you'll see there's a JSON RPC thing. Use JSON RPC to interact with the node. A node is a network client connects to a peer-to-peer network of other nodes. Nodes process blocks, publish blocks, and do all that blockchain stuff. Luckily, the software you're writing that creates the transaction to transfer tokens, in our example, from Alice to Bob. So Alice doesn't need to speak the blockchain Solana language. She can just talk to JSON RPC to the whatever node she has access to. So as you can see, everything is a get. So it's mostly fetching account information and chain state. However, there's one that she'll need to get the transactions of the block, and this is the send transaction. So for send transaction, the story's a little different. There is a process by which Alice has to follow to get her transaction into a block. Essentially, let me switch tabs here. This is my diagram here. Essentially, previously, Alice would have been able to, as a user, shoot her transaction directly to a leader. So in a proof of stake system, you have a bunch of nodes. In Solana, they're called validators. So vocabulary warning. Validator is the network node. Those are the same thing. So heretofore, I'll call the nodes validators. Um, so for every slot, there's a leader. A leader is a validator picked according to some schedule calculated on chain uh, ahead of time. The leader is the one who creates the blocks, which means everybody's got to get their transactions to the leader. And then I said up until now, users have been able to talk to the leader directly, give the leader their transaction, and then the leader puts it into the block. But the problem with this approach, as you can see, let's see. As you'll be able to see in this GitHub issue, it's like network stability. There's no traffic control when everybody can talk to the leader. So you just end up with a de facto denial of service attack when people want to send transactions. So the solution is for the Solana devs to roll out quick QoS and fee markets. In this case, fee markets applies to the writing to the account, so writing state. Our focus and our solution is to deal with these two. Quick is a handshake between validators, and QoS stands for quality of service, which is basically a rate limiting mechanism. Actually, we can see down here, where's QoS? Yeah, so I'll load up QoS. Is basically QoS basically essentially says your bandwidth to the leader is restricted by the amount of stake you have. So in this graphic example, can you see my mouse cursor when I'm pointing at the PowerPoint or
Yep,
the
I could
slide?
see it.
Oh wow, okay, that's good news. So in this diagram, I have the validators. The arrows reflect the bandwidth that validators have to the leader to send transactions. The bandwidth is proportional to the amount of stake they have. And the stake is denominated in SOL, S-O-L, which is the base unit currency for Solana. How you doing, Miguel? Makes sense so far?
Yeah. So basically QoS is the rate limiter for number
Yes.
of requests being sent.
Yes. And yeah, exactly. And so if I'm Alice, I need to do a deal with one of these validators to piggyback on their bandwidth to send my transaction to the leader. So this is less of a blockchain problem, and this is more of a business problem, because why is the validator going to let Alice send the transaction through them? You could do it on if I'm a validator, the validator is like, well, I guess the validator could just be nice and just say, look, I've got some spare capacity, give me your transaction, I'll send it for free. The validator could also say, you know what, you need to pay me like 1,000 SOL a month or something, or $1,000 a month, and then you can send as many transactions as you want through me. Let's do a deal between me and you. So in this case, Alice just kind of like software as a service goes to a web page and signs up with a credit card or something to send transactions through some validator. Or in this case, when we have a solution called Solpipe, that's specifically designed to let validators sell their bandwidth. And we try to do as much of that on chain as possible. Okay, so in summary, we need to auction the bandwidth continuously to users like Alice. Well, let's see how we do that. All right, so we're going to do a bandwidth auction. So what is that? So basically, a validator has some stake, so people can calculate their bandwidth. Bandwidth we measure in TPS, or transactions per second. It's pretty simple way to do it. Blocks are published in slots, so maybe some people might want to do it transactions per slot, but I think it's easier to do it by TPS because humans understand seconds and transactions. So, how does it work? So Alice developers, they deposit funds in kind of a bid bucket that's specific to. In this example, we'll use validator, but in Solpipe, it's a little bit more complicated. But in this example, Alice deposits money before the duration, the period starts. If 10 developers deposits $10, by the way, the auction will be done in USDC instead of Sol, because most of the business expenses, at least in my experience, are in dollars. So a lot of the people I've talked to would have indicated a preference for their expenses being in dollars and not having to have the Sol kind of FX risk. So Alice is depositing dollars. If when the period starts, right? So let's say the period starts tomorrow, 3 p.m. So at 3 p.m., the deposits will be locked. If there are 10 developers, including Alice, and they all deposit $10, the bid bucket is the sum of all the deposits. It's $100. So Alice has deposited $10. So her TPS allocation is 10%, right? It's just a ratio. The 10% of so there's another. Yeah, so I'm on number 4 right now. So, oh, Miguel, do you have any questions so far about TPS allocation? It's basically however much you deposit, take a ratio, and that's your allocation.
Yep, I think I got it.
Okay, and the TPS number that comes from just the total network capacity plus whatever bandwidth the validator gets with the leader. So, which is roughly like if there's 100 Sol and being staked on validators, and this validator has 30 Sol, that means the validator has 30% of the network capacity. So, roughly speaking, 30% of the network TPS.
Yep.
Okay, cool. All right, so one issue that came up when designing this is like I didn't want to have a situation where for every period that comes through that that is set for a particular validator. We didn't want a situation where like you have to keep pumping in money for each bid. So what we did is we have a decay process where the bid bucket it starts at $100. Instead of all $100 at the beginning of the period going to the validator, we have we have something called a decay rate, and a decay rate, if it's 10%, as we have in this page here, then the $100 will go to $90, and the $90 will apply to the next period, and 10% of the decay rate of the bid bucket becomes the fees, part of which goes to the validator, cranker, controller, and actually another part goes to well, let me get to that in a second. In this page, I really did try to simplify things. The validator includes stakers. So a staker is someone who has Sol and they like pick a validator and they stake their soul with the validator, and a validator can have multiple stakers. Um, okay. Today we'll focus on the validator and staker part. Okay, so well, this thing needs a bit more labeling, but I mean, essentially, the gray boxes are all the accounts on chain. Um, actually, I changed the name of this manager. Um, so I have to introduce a new concept. That's a pipeline. So basically, the pipeline is a proxy in our case. In the Golang code, the proxy is basically this yellow box is kind of it's a I mean, for lack of a better word, I call these yellow boxes agents, but they're just basically programs that run online, and these programs manage the on-chain state and also perform the service of delivering the bandwidth. So you have the bidders, which are developers, and to send the transactions, the bidders go through the pipeline. Then the pipeline then goes to the validator. Does that make sense?
Yep, it makes sense.
Oh, okay. Um, so it's kind of like this. So then in actuality, when the the bidder is depositing money into the bid bucket, they're not depositing money that goes to the validator directly. They're actually depositing money that goes to the pipeline. Pipeline is the kind of like a broker between a bidder and a validator. And the pipeline is the one who hosts sends transaction RPC proxy. Let me go back to the slide share. Does that make sense so far? Okay.
Yep.
So, for us, we have to write a Solana program, a smart contract that connects the logic for all these different things, all these account on-chain state. And we also have to write in Golang, I have to write the programs that manage the on-chain state and that run the transaction proxies and do the rate limiting. So each of these items are Golang programs that have to run on a server. So the pipeline's job is to manage the bids and to create the periods. So the pipeline's running the kind of the bidding cycle. Everything on this side is basically about counting money. So when a period starts, when a period is created, like for example, the pipeline is going to create a period for 9 a.m. tomorrow. The period's going to last 2 hours. So then the pipeline has like a list of periods that are coming in. There's a period that's going to start at 3 p.m. today that goes for 6 hours to 9. Then there's going to be a 15-hour period after that goes from 9 till what's 15 hours 12 hours. So there's a second period coming in that's from 9 p.m. to 9 a.m. So this 12-hour period. And after that, we put in a third period that starts tomorrow at 9 o'clock, and um, it goes for 3 hours till 12 p.m. tomorrow, from 9 a.m. tomorrow. Uh, we're okay on the period part.
Yep.
Okay. So again, just to refresh, the bidders, basically developers like Alice who have a transaction to put into blocks. We're on the assumption that people like Alice have a business, like a website, like for example, Mango Markets or some trading website, and have a stream of transactions that they need to get into blocks. And it's traffic management. If their website gets 10,000 hits, maybe out of those 10,000 hits to the websites, they're getting 5 transactions a second or 2 transactions a second or something. So maybe tomorrow, Alice is not just sending a single transaction. Alice is running a website where people send transactions. So Alice is now running a website in the example. Alice is needs from 9 a.m. tomorrow to 12 p.m. tomorrow for 3-hour chunk. There's going to be a lot of people online, and she knows she needs not 2 transactions per second, but she needs 5 transactions per second for 3 hours. So in a 3-hour period, that's the third period in the pipeline coming in, which looks like this. So well, it's a 1-hour chunk here, but in our example, well, we're in a period right now. Then the next period starts at 3. Then the next period starts at 9 p.m. Then the next period starts at 9 a.m. the next day. So if Alice is focusing on this period, and she wants to make sure that when this period starts, she can start bidding for this period. And when she starts depositing money, she has to make sure that she gets 5 TPS for this period, which means she has to watch out for like how much money are other people depositing. If they deposit more money, then she has to deposit it such that she gets 5 TPS, roughly speaking. Does that make sense?
Yep. It's
Okay.
similar to outbidding other validators.
Yes. And if you've Miguel, haven't you dealt with like marketing stuff where you have to bid for like what's it called? Keywords or something?
Yeah, yeah.
Maybe. Yes, that's basically the same thing. And the keyword stuff for marketing and online uh, advertising, that's by time period as well.
Yeah, I think there's a certain keyword limit per day
Okay,
that, yeah, for bidding.
so it's the same system as that, um, except you're bidding for TPS instead of ad share, mind share. Okay, where am I? Pipeline. So I mean, this is what the bidding cycle looks like. We just talked about, the bidding part, which is the green part, which is like what you do. Well, okay, we talked about the part, like we're in the white chunk right now, where Alice is worried about tomorrow between 9 and 12, and she wants 5 TPS. So she's bidding now. Let's say time machine. It is now, what is it now? It's 9 a.m. tomorrow. So the clock ticks and the period starts. So now we're on the green line. Um, So there's a bid table. It's got a list of everybody's bid, which is basically their deposit size and etc. From the bid, the uh, the the pipeline that acts as a proxy will read in the allotments. The on-chain program will calculate everybody's bandwidth share, and Alice will get. Oh man, these numbers aren't round, but let's say she needs 5. Let's say the pipeline she bids on has 20 TPS. So in this case, she gets 25%. If she's bidder 4 here, then she gets 25% of 20 TPS. So she gets 5 TPS. So she gets her goal. Um, so the bid allocations are calculated on chain, and then they're read in by the pipeline, which is a Golang process that acts as the send transaction proxy. That information is okay. So then the revenue information gets fed into payout. So payout is a temporary account. Um, Payout is created. So a bid and period accounts, you could think of bid, period, and pipeline as like one big account. It's just there was size restrictions, so they're separated. I didn't put it like a black box here. The black box indicates there are many accounts to one account. So one to many relationship is with a black box, and one to one is
Mhm.
just no black box. Make sense?
Yep, makes sense.
Okay, okay. So right. So when a period is created by the pipeline, a payout account is created. Payout account is temporary. It's used for accounting. Um, then what has to happen is the payout is between the is for the period, and then the validators have to pick the payout. And when the all right, sorry, Miguel, this is the first time I'm explaining this. We're gonna have to go through like 3 iterations of my explanation for it to be smooth. So let me go back to the validator, right? So the
Yep,
validator is the one who actually talks to the leader, right?
yep,
But the bidders talk to the pipeline. Pipeline proxies the transaction to the validator. But actually, you have multiple validators here. So the pipeline actually sends transactions to a set of validators. But how does the pipeline know which validators to send transactions to? Well, what happens is need to, the validator has an online account called a validator manager. And the validator manager account basically lets the validator pick which payout the validator is on. So on the bidding side, I have to know the TPS of the pipeline. The TPS of the pipeline, I need to get that data. I need to get the total stake of the validators, of all the validators who picked this pipeline, because there are also multiple pipelines. Makes sense so far? Kind of.
kind of. Yeah.
All right. Let me do an arrow because I think an arrow makes sense. So basically, the validators have to pick. Let's see, orange. The validators have to pick which pipeline they're going to do stuff for. And they do that by creating a receipt account. So I'll mark it orange. The validators mark a receipt account. And a receipt account basically tells everybody on chain, like, hey, I have 30 Sol and I'm going to pick this pipeline. I'm trying to think of another. So the validator could sell their bandwidth to any of these pipelines, but for this period with this payout account that that corresponds to the period tomorrow from 9 to 12, validators like, my stake will apply to this pipeline for this payout period, this period. Okay.
Yeah, I think that makes sense already.
Oh, okay. All right. So, yeah, and that's described here. The validator, well, it's just a technical thing. The validator separately, independently, has to run some Solana transactions using this Solpipe program, smart contract, to, for example, I mean, not for example, but first to create a manager account that basically matches a admin key to their vote key. The vote key is very sensitive, so we don't want to use that too much. And once we have an admin key that's not as sensitive as the vote key, the validator manager can now pick which pipelines to do business with on chain with vis-a-vis the receipt account. Staker is not quite the same. Staker, through a separate process, delegates stake to a validator, which is parallel. But the staker manager needs to assign an admin key to their stake so that the stake, the person with 30 Sol or whatever stake, can claim the revenue from the pipeline. How am I doing on time? Oh, not bad. All right. So in the green part, the validator. This is receipt. I'm renaming some stuff while I do this explanation. I'm making some logical corrections here. So the validators have to, in this green line, when either when the period starts or before the period starts, the validator has to register itself, and the stake has to register itself as well. The reason why is how should I phrase this? So in Solana, right, all the revenue information and deposits are coming from this direction, from left to right. But all the supply side information is coming from the right to the left. And we kind of have a pie chart. There's a revenue split. it's going to be between the pipeline, pipe fee, which is a percent. There's going to be a validator fee, which is, I guess, 1 minus payout share. And then there's going to be stakers, which is Sol share percent times payout share. Does that make sense? So there's a trick where you have to figure out how much money to pay everybody. So in the green line, before the period starts, everybody's got to register. Like, hey, I'm a validator. I'm with you, pipeline. So any bids you get, you got to pay me. And then the stakers have to watch the validators. The validators will create these receipt accounts for themselves, and the stake have to register themselves with a payout account and say, hey, pipeline, this validator registered with you for this period. I have 5,000 sold, so I'm registering. You need to pay me out. And then what happens is when the period ends, there's in Solana it's called a crank, but somebody basically forces the payout logic to execute. And then that's what this red line represents. And basically the total revenue is stored in the payout as part of the state. And then what happens is, the validators, there could be, for each pipeline, there's multiple validators potentially. Each validator is like, look, give me my payout. And how does this work? Wait, I have to recall. What was the logic? This logic is actually quite complicated. I think the stakers have to go first. The stakers have to claim their payout because the stakers have the relative weight of their stake, and the validators get a piece of the stake revenue, as you can see from the payout share. So these two lines are paid out in accordance to the weight, the stake weight. So the stakers go to the payout first and say, here's my stake receipt, pay me money, and pay the validator money. And then through these transactions, the Solana program vis-a-vis the payout account and stake receipt account will pay the bid revenue. So the USDC money, it will go to the stake receipt and to the staker. Then once all the stakers have completed their withdrawal of money from this payout account, validators then come up and say, look, the stakers have all withdrawn their money. It's my turn to get my payment. And the validator will just present their receipt account to the payout account, and the payout account will say, well, you have this much money left. Here is your USDC. Then once the validators have pulled out their money, the rest of the fees, the pipeline fees, go to the pipeline account, which is run by somebody. They get their cut. Actually, there's one more person who gets a cut, and that's the controller. But the controller is basically the person who runs the contract, the Solana program on chain, which is basically, us. We get the controller revenue. So, all right, does that make sense? It doesn't make sense, but it was a lot of shit. Well, and it, not supposed to cuss in the video. That was a lot of stuff.
Yeah, but yeah, I'm still taking it in. But yeah, I get the point already for it.
Yeah. I mean, if you're coming from an SQL background, right, you have like two tables with the join in it, right?
Yeah, yeah.
But in Solana with the smart contracts programs, you can't do SQL join in the program. Um, it's weird. You cannot. If I'm a child, I can point to the parent. So you can consider the accounts on the left are kind of like the parent accounts,
Mm-hmm.
and then the accounts on the right are kind of children account because the children account reference the parent
The
accounts.
parent. Yeah.
Uh, Children can point to parents. Parents cannot point to children, and that is the primary restriction when trying to figure out how to do this.
Okay, okay. Got it, got it.
Yeah, I mean you'll see in the Golang code I walk you through. Um, which actually I have to refactor some of it today because I changed in preparation for this explanation to you. I figured out some bugs, shall we say, things I have to rewrite. Okay, so I mean that's it. I mean it's really, you know, the majority of the work is on the bid cycle. Um, so let me go back to here. So let me just do one more arrow. Do you need like a 5 minute break after that? I just want to do another 45 minutes for the what's it called? To walk through the Golang code.
Yep, maybe 5 minutes.
All right. Um, Peace. I'll just mute.
Okay.
All right. See you in 5 minutes.